So welcome to the afternoon session. My name is Shirley Alexander. I'm Deputy Vice-Chancellor, Education and Students. That means I get to chair lots of panels at lots of conferences. I get to open them. But this is probably the most exciting one for me because I am actually a lapsed statistician. So I worked with Don McNeill, if anyone remembers Don McNeill. And I think education is really important. It's a really important thing to me, and one of the projects that I'm trying to drive through UTS is that we have a dream that one day numeracy, a subject on numeracy, is going to be compulsory for every graduate from this university. At the moment it's being rolled out as an elective. I'm really sorry I missed Shelley's talk this morning because what we're trying to do is to put into practice what I understand he spoke about, which is getting people interested in the ideas of mathematics and statistics without actually having to do what they often consider is the hard sums. And once we've got them, then we get them into doing the really interesting detailed work. So we have a subject, it's called Arguments, Evidence and Intuition. And it is being rolled out. I'm also quite known for having cleared a whole table at a fundraiser for the Sydney Children's Hospital by mistaking politeness for a genuine interest in very basic probability theory. There was a raffle going on with quite expensive tickets. I think they were $50 each, and a couple at my table bought 5. When the first draw was made, they won first prize, and they got up and said, we might as well leave, then we've got no chance of winning any more prizes. So I said, no, they're independent events. And I started talking, and my husband was saying, be quiet, no one's interested. I said, no, they really are. And eventually everyone was gone. So I hope I do a better job today of chairing this session. So the way it's going to run is that we have some outstanding panellists, and I'm told that they're going to speak for a maximum of 10 minutes and that less is more. So I'm not sure how I'm going to tell you that you're approaching your 10 minutes, but maybe I'll get up and stand behind you if it's over 10 minutes. So we might start with Anna WETHERELD, who's sitting beside me, who has what sounds like a dream job at the Board of Studies as the Mathematics and Numeracy Inspector. I won't read out her whole bio because I'm sure that you've all got her bio and that you're all quite capable of reading that yourselves. So I'll hand over to Anna.
Thank you. It's really wonderful to be here today, and I wanted to thank all of the organisers for actually providing myself and my staff the opportunity to come along, because I found today exceptionally inspiring and also in many ways very affirming around the different work that we're actually doing at the Board of Studies at the moment. One of the things that became really evident today, which wasn't surprising, is that we are all in the same business here, and it is about nurturing the talent and our learners here in Australia to keep ourselves at that leading edge. But what was very obvious is the tension that so easily is created by the various different perspectives that we bring to this conversation at the moment, and obviously in trying to achieve our own personal goals or organisational goals. What I think we have to ask ourselves is that we are in a customer service kind of area in the universities and schools, and what is the customer service experience and product that we want our students to come out with? Now, I'm talking very much in that K or F to 12 space. So for me, it's really about ensuring that here in New South Wales that we create opportunities for our students to become critical, creative and discerning mathematics learners who are able to function statistically literately in their everyday lives and so on. From the BOSTES perspective, it's been really interesting. I've been here for approximately 3 months or so in my role. I originally came from Queensland, so I'm getting to learn about a new system and a new approach versus the old Maroon way that I've been with for the last few years. In BOSTES, at the moment, we are, as Rob put up on the screen earlier today, in the process of syllabus redevelopment, and in particular in math, science, English and the history space. Now, there's stuff that, because it is an election, that I can talk about, and stuff that just watch this space because it will actually appear hopefully fairly soon. You will see that last week we actually released the writing briefs around each of our syllabus documents. And one of the inclusions in there was actually statistics. And this is a slight shift, you could say, here in New South Wales to actually incorporating statistics into all of our courses or some of our courses versus simply being in the general space. Now, one of the things that we really have tried to ensure is that through the development process that we have collaborated wherever possible with experts. Because whilst I work in that K to 12 space, that doesn't mean that I'm completely informed on what happens in the tertiary or the industry space. So I think it's vital for those sectors to also have a voice in the design and the way in which we articulate our curriculum. So for those people that have actually helped us, I wanted to acknowledge that we very much appreciate the work and the voice that you've brought to the party for us. The challenge in all of our states is obviously engagement in our maths courses, and in particular in our higher level maths courses. So as we're trying to refine, redesign what we do here in New South Wales, we really are trying to look at what are the ways in which we get students to choose to come on the journey until the end of grade 12 and then hopefully into your sectors in the university and in statistics. As Rob Randall mentioned, one of the challenges being a curriculum organisation is that for us it is around the formal curriculum, and there is a very big tension then with the pedagogical approaches of our teachers. And so I guess that brings me to a couple of really critical considerations for us. And the first one is around the content support. Now, in New South Wales, statistics hasn't always been in that senior space. So with its introduction there means that we are going to have to provide quite a lot of substantial support to teachers to ensure that they adequately and appropriately teach our students and impart the enthusiasm that I've seen in this room today. So I'd like to think that by being part of this, that we will create a dream team, but what's very important is creating that team dream for, we've got the dream team, but we need the team dream to be out there in New South Wales. So in the design of any support materials and so on, it has to very clearly articulate the vibrancy that all of the voices that I've heard today actually speak with, and also hopefully mathematically have it appropriate. Now, I loved the Tetris versus Minecraft example. Often I think that when we design curriculum, we do think about it in certain cells and putting together things nicely in a tetric kind of pattern. But it's not that easy because you have to get everybody to come on the journey with you. So simply producing a paper document is only one part of the journey. The rest of the journey is taking that plan and adding meat to that bones and actually creating the dynamic vibrancy that is statistics and that is maths. So I think we need to look at not only a core approach but an interdisciplinary approach, really showing that within the maths curriculum that everywhere there are opportunities for extended exploration and ways to invigorate the curriculum so that students see its applicability in all areas. So I enjoyed when Nick talked about that you've got PE teachers, you've got all these other different teachers that could teach statistics. And the truth is, yes, they could, but we need to arm them with the right set of tools and pedagogies to do our subject justice. And I think that's absolutely vital. The other thing we need to think about is assessment and where its place is, and how do we assess that our students are actually statistically literate, not only mathematically literate, and also where the place of technology is. Now, here in New South Wales, currently, the minimum technology that we use for HSC is a scientific calculator. But in the design of the curriculum, we are looking at trying to infuse throughout it the use of technology. And I think statistics creates a really great opportunity with the right support documents to actually showcase how the two can go hand in hand. And I guess one last little thought that I think will help inform the way in which curriculum statistics across all of our junctions actually can be optimised, and that is, as Helen put it, through the transformational use of data. Not only as teachers in our classrooms as we differentiate our learning for the vast array of students that sit in front of us, but that we as a collective group also apply that same mechanism as we use the data to optimise outcomes. So thank you very much. Not 10 minutes, my dance.
You had 1 minute and 30 seconds to go. So you talked about how we know when our students are literate in a statistical sense, and it reminds me of many, many years ago when we had a state minister for education who gave a press conference and said that she was appalled to find that half the K-12 students in New South Wales were below average in mathematics. Now, I normally have to explain that joke, but I know I won't have to today. Our next speaker is Professor Geoff Prince, who is the Director of the Australian Mathematical Sciences Institute. He's been at RMIT, University of New England and La Trobe. He currently holds an ARC Discovery grant with Phil Broadbridge at La Trobe. Thank you, Geoff.
Thanks. Thanks very much. So I just wanted to hang my remarks really off a couple of things in the decadal plan, since this provides us really with a good opportunity for review and overview and so on. So, and I want to make comments about the adequacy of current undergraduate courses and in the mathematical sciences, and I want to make comments around the teaching profession and the preparation of the teaching profession. So, let me start by reading the ones around teaching at Australian tertiary institutions. So this is around the preparation of our graduates. So there's in the decadal plan there are 3 recommendations in this area. Now I should just say that there is a companion document to the decadal plan, which is available from the Academy's website, which contains a précis of all of the 7 subcommittee reports. So the subcommittees were by domain, and so there's a précis of those reports with the recommendations, and that's a companion volume. So for this group, that is an important document. This is an external facing one. So the recommendations here are by no means all the recommendations in the plan. But let me just read this one about our engagement at university level. University deans and heads of school in disciplines outside the mathematical sciences should facilitate liaison between university mathematical sciences departments and those expert in the mathematical and statistical needs of these disciplines to see that the appropriate subjects are being taught to students in fields such as engineering, science, commerce, economics and education. And the commitment that we make in the plan to that is that the Australian Mathematical Sciences community will communicate the importance of our discipline to the Australian public to counter the widespread ignorance of the extensive range of careers pursued by mathematical sciences graduates, and we will continue to maintain the very highest standards of teaching and engagement, and will support the viability of mathematical sciences programs in our universities. So, you get what the recommendation's about. The recommendation is about making sure that mathematics and statistics are taught effectively outside of our own disciplines into other areas. So I think we all agree this is critical in this age of data, that it is particularly important that there is a high level of statistical literacy amongst university graduates, especially STEM graduates, but also business graduates as well. And it will involve our engagement. So we could leave it up to those disciplines to try and provide this statistical literacy to their graduates. But I think as mathematical scientists, we feel somehow that we're best placed to do that. As long as we do it effectively, and we have a good engagement with those areas that we have to service, we are the best place to do it. I personally believe that, and certainly the decadal planners believe that. So let me tell you a salutary tale about this. I was recently visiting a business school at one of our universities who had put in place a Master of Business Analytics. And they set the bar pretty high for statistical knowledge of, prerequisite statistical knowledge of the graduates who are coming into this MBA, as it's called. And they told me that when they were planning this MBA, they got in touch with the Computer Science Department of the university and the Mathematical Sciences Department of the university in order to get collaboration on the delivery of the subjects. And the computer science people answered the email and came knocking on the door straight away, and they didn't get an answer from the Mathematical Sciences group, not even an acknowledgement of an email. So we have a long way to go on this, and in fact that recommendation, which says that these other disciplines should facilitate liaison, right? I don't know who wrote that. It wasn't me. There's an sense of entitlement there, and from our perspective about this, and that's reflected in the story that I gave you. We have to do better. Our leadership has to do better at this. So that's a comment that I'd like to make to all of you, because I think it really is important that our commitment on this is a real commitment, and that we are the first ones to make these connections in places where they don't exist now, and where they're growing now because of the age of data. So I think that's the first thing I want to say. The second thing is that as far as the preparation of our graduates is concerned, in general mathematical sciences, so statistics and maths, undergraduate education takes place in science faculties, and I have to, in the framework of a science degree. And I have to say, and I've always felt this my entire life as an academic, that science degrees are really just dinosaurs. When you compare them to an engineering degree, in which an engineering student has some placements, they do project work, they have to do collaborative work, they learn communication skills. Now, admittedly, these might be formal requirements of the degree, and you might argue that engineers don't really get these things, but in general, the structure is there. In a science degree, you get nothing. You go to an employer with a science degree, and the best you can put on the table to show them is your marked assignments, right? Now, how rubbish is that compared to an engineering student? So we have a long way to go in the undergraduate preparation of our students in order to make them professionals. And while we might say PhDs should be full of communication subjects and soft skills and whatever else, I think our science degrees are letting us down badly. And it's the science degrees we should be looking at, and not shifting the responsibility to PhD programs. Now, having said that, I'm now going to sort of maybe move over to the teaching issue. And then, if I have time, I'll come back to what our Industry Advisory Committee found recently when they interviewed 25 senior company executives and 5 agency leaders. But coming to the school teaching situation, it is the case, still in Australia, you can take a maths degree or a maths major without doing any statistics subjects. And it's also the case that you can take a statistics major inside a science degree with only first year maths. Now, I think it's, when we've talked about breadth of knowledge and domain knowledge outside of our main area, I think it's absolutely crazy that any maths graduate, so somebody with a mathematics major, not a statistics major, can do so without having enough stats in their degree. That's crazy. We are letting our students down. We can't let them out there into the workplace without enough statistics in the 21st century to be able to deal with data competently. And that's the situation at the moment. The maths majors really do need a hard look at themselves. Graduate attributes for maths majors ought to include a very significant amount of statistics. And I would argue that if you're doing a stats major and a science degree, you should be getting exposed to the sort of sophisticated mathematics that you need in order to be able to stay up to date as a practicing professional statistician. Now, of course, there is a corollary to this observation about our problems with science degrees, and that is that when we're graduating maths teachers, and we're not graduating nearly enough of them, if the maths teachers are coming out with the minimum requirement, even with a maths major, and there's not too many of them, they in general will be going into schools, well, significant numbers will be going into schools without having done any university statistics. It's crazy. It's absolutely crazy. And it's one of the reasons, I'm sure, why we have this perceived problem with statistics in schools. Because our maths teachers, the people who have carriage of those subjects, don't know statistics. And they haven't learned it from statisticians, and they need to. So we have a very significant problem there. And the other aspect of this that's really important is that when we are looking, as the decadal plan says we should, to provide out-of-field teachers with professional knowledge and pedagogy knowledge, the professional knowledge they need is statistics as much as it is mathematics. And when we're designing out-of-field teaching professional development, we must keep in mind the critical role of statistics in that body of content knowledge they need. So, in my view, a very significant task that's in front of us and that is actually doable by our discipline, to be frank, without needing the stamp of the dean or the university or whatever else, but is a discipline problem, is overhauling our maths majors to make sure that there is a significant amount of statistics and looking hard at our stats majors to see whether we're servicing the future needs of those graduates. So I think we should be doing that, and I would urge the Stats Society and the Maths Society to get together on issues of accreditation for degrees to pursue this goal. How much time have we got? 22 seconds, right. So, our Industry Advisory Committee met this big group of executives, and the change, and we found in general the sort of things they required was coding. So coding is for their maths capacity, for their commercial maths capacity. Coding is absolutely critical. But the difference this time from when I'd done this sort of exercise before, now data was absolutely central and a necessary condition. So they wanted SQL, they wanted all of their mathematical scientists, no matter they were mathematicians or statisticians, to have that data stuff. And we need to focus on providing our graduates with those skills. Thank you.
Great. Thank you very much. Our next panellist is Jackie Ramage, who caught my eye when I walked into the room today because she was wearing her name badge in her hair. And she explained that there are very few women in mathematics and statistics, so it is a way of standing out. I thought that was very unique. I've put that into my ideas list. So Jackie is the head of the School of Mathematics and Statistics at the University of Sydney. She is a pure mathematician. She's on the College of Experts for the ARC and on a panel in New Zealand, served a CARA, won a teaching award, and thinks that mathematical sciences are the key to economic prosperity and believes that we should be supporting everyone to become as highly skilled in mathematics and statistics as possible. Absolutely. Go, Jackie.
Thank you very much. Just to clarify, I'm not on the College of Experts at the moment. They've let me off the loose. Off the noose. Yeah, there's a Freudian slip for you. Okay, so I've been listening very attentively today. I think I can add some things, and I want to reinforce everything that I've heard so far. One thing I would say at the outset is that Australia has an absolutely massive problem in what I would call informatics. There's a massive disconnect between the demand from industry on the one hand for computer science, mathematics and statistics, and the supply of people with skills in those areas. And of these, the deficit in statistics is the most acute. At the same time, I do believe that they are, as three disciplines, a lovely triumvirate in informatics, they are the foundations of Australia's future health and prosperity. So I think we do ourselves a great injustice to ignore the problem. We're just burying our head in the sands and doing ourselves an enormous disservice. Industry, as you've seen today, is beginning to notice that there is a problem. Unfortunately, by the time industry really wakes up, our educational system will have imploded. because the demand for graduates from industry has been so great that it has, for many years now, been starving the teaching profession of personnel, as more and more people go into industry who would otherwise have gone into teaching. So I do hope that they wake up very soon. One of our big problems is visibility. And Nick referred to this during his talk. He said not many jobs are advertised as for statisticians. I would go further. Very few of us have mathematician or statistician tattooed on our forehead. So even when we're in those jobs, it's not obvious to anybody that that's what we are and that that's what we're doing. And I think we need to make a massive effort to try and increase this visibility. And that is a plural we, because we have a role there, but so does industry. So Nick said that we have to communicate the attraction of a career in stats, absolutely. But Steve Davis from APRA, the Prudential Regulation Authority, said to me something very wise one day. He said, "Your words have much more impact coming out of my mouth." And so ever since then, I have made it one of my jobs to try and feed industry the right words. And I think we all need to be doing that, and industry needs to be taking on that challenge and speaking on our behalf, because the rest of us all have vested interests. And whenever we say anything, it is possible for people to say, oh yes, but their livelihood depends on it because they need students. Whereas when industry says this, they don't get faced with such criticisms. It's clear they have a vested interest in it, but it's because they want to give people jobs, and so it's a completely different kettle of fish. So industry needs to actually say something about the problem and identify the problem. And nothing speaks louder than money, unfortunately. So industry really needs to put its money where its mouth is. It really needs to set up scholarships targeting people in informatics and saying, we want these people. For every scholarship that they would set up, there would be many more people who would consider undertaking those degrees because they would see that there was a demand. Their parents would not be so worried about them getting a job. One of the most common questions I get from students, prospective students, is, why should I do maths or stats? I don't want to become a teacher. And one of the most common questions I get from parents is, well, will my child be able to get a job? To which I always respond, it's not a question of whether they will get a job, it's a question of which of the jobs they're likely to be offered they will want to take. And that message is just not out there, and we have to keep putting it out there. But we also need to engage with industry because our words have much more impact coming out of their mouths. So they need to send that message, and they need to send it forcefully. I was very pleasantly surprised by the Australian Public Service Initiative to actually take people and retrain them in statistics. I think this is great. Why didn't I know about it? I don't know, can you put your hand up in the audience if you'd actually heard of this before, if you'd come across this? Yeah? So nobody knew that this was happening. And in fact, industry should be doing this, and possibly is, for all I know. We liaise very much with AMSI interns, which is a great initiative. And when companies come and say to us, we want statistics PhD students to come into our companies, well, yeah, we'd love to send you more, but we don't have more. How about you go and you look at your staff and identify somebody who is appropriate and send them to us to do a PhD? And then you'll have a PhD in statistics. It's not rocket science. But we really have to make that point and engage with people. Obviously, more engaging teaching is needed. I absolutely, categorically agree on that one. So we can have death by decimals or any such thing. But I think, particularly in universities, there's this false dichotomy between research and teaching. There's a false dichotomy between research excellence and teaching excellence. People think it's either one or the other, and it's not. You can be absolutely outstanding at both, and Harvard is the perfect example, and Shaoli illustrated that this morning. Harvard proves that you can be both outstanding at research and at teaching, although, of course, a $36 billion endowment helps in that regard. And resourcing all of these things is our major issue. The one thing that the US in particular, and Harvard in particular, has picked up on is the idea of moving outside the system. People have been referring to customers and products and so on. And when you look at the forces on industry, really, we need to move outside the system to get appropriate income to resource all of those things. And this is where all the philanthropy in the US, and that has made a massive difference to the ability of institutions to deliver on those areas. The other thing, so I had the privilege of spending some time at Harvard last year, and the other thing that is very, very clear is that there is a culture at Harvard that supports teaching excellence, as well as the research excellence. And I think culture is incredibly important at all levels, at the university level, at the school level, and just at the societal level. And I think one of our big challenges, one of our big revolutions that we need is a cultural revolution. We need to move from the concept of talent to the concept of work. It's not natural, innate talent that makes somebody good at maths and stats. I know some very talented people who have done no work at all and got nowhere, and I know some people who were ostensibly less talented than them initially, who by working incredibly hard have done amazing things. So hard work will get you there. It's not a talent issue. We should stop thinking in those terms. That's one of the problems. And the other problem is just the language we use around maths and stats, and the way that we often self-deprecate or belittle the disciplines, or indeed, even worse, our colleagues belittle our disciplines. And I have seen some examples of that. And I always make a point of calling those out because it hurts. I mean, it hurts personally, but it really hurts the discipline. And when you're in a situation where you've got students in the audience and somebody is making a joke out of maths and stats, what are those students going to feel? Why would they go into a discipline where people are denigrating them? I mean, it's very, very distressing and counterproductive. So on that culture point, I'll just end on the note that my background is Spanish, and in that culture, it's just expected that everybody's going to be doing mathematics. There is just no question. Everybody does mathematics. And it's so embedded in the culture that there's actually a mathematical insult. And so in Spain, somebody can say, translated, "You are more useless than a zero on the left." And everybody knows what that means. So I don't know, maybe we need some sort of competition where we're going to invent a mathematical or statistical insult and see who comes up with the best one. But it's a great indicator of where we are culturally, that too clever by half is an insult. But you're more useless than a zero on the left doesn't exist in our vocabulary. Okay, that's it. Thanks.
Thank you, Jackie. I now have a new anecdote. So I was wondering how our next panellist snuck in, because I saw that he has a PhD in astronomy from ANU, but it's okay because he's a predictive modeller at Qantas Loyalty. He did get his PhD in astronomy from ANU and has worked in a diverse range of organisations: stellar astronomy and astrobiology, bioinformatics, educational modelling, and marketing optimisation strategies. So over to you.
Thank you for those kind words that I wrote. I would probably not consider myself a proud statistician, but I'm definitely not proud of not being a statistician. So, Professor, I fall outside of your box. But what I could say is, I've been very fortunate to have worked for really, really brilliant people. Well, to work for some brilliant people, but why? And this is the result of what Xian and Roslyn and Hamish have so eloquently put. This almost exponential growth in the demand for statistical knowledge. I think in your graph basically starts picking up from 2004, and it really, really goes high. And I'm thinking, well, why is that? It's probably because since 2004 is when big data, by virtue and the miracle of cheap computers and internet, starts becoming mainstream. And then it starts trickling down from pure research all the way down to government and banks, which obviously have resources first to adopt it. But then it keeps trickling down, for example, for grocery shopping, where loyalty programs have massive leverage on knowing every single purchase that you do. Imagine the leverage to know the customer behavior from then on. And it keeps trickling down, right? Like last month, I went to a data jam or a hackathon, whatever you want to call it, where we spent, it was 10 groups of 5 people, 12 hours with all the data from the state of origin from New South Wales versus Queensland. And we spent 12 hours trying to do whatever insights I'm predicting and throwing the kitchen sink at it and trying to give some advantage to the New South Wales team. They probably are very happy today to blame it on the data scientists, so that is great. But I guess the question is, why? Why is this exponential growth in the demand of statistical knowledge? Well, and Peter was mentioning this yesterday. Statistics is the language of measurement. I do come from an astrophysics background, and we used to very proudly say, physics is the language of the universe. That's beautiful. It's romantic. It's dramatic a statement. But in the cold, hard world, statistics is the language of measurement. And the ability to understand problems and to provide reliable, robust measurement translates into jobs. Not normal jobs, not any kind of jobs, jobs that are interesting, jobs that are challenging, lucrative, maybe even a combination of those 3 things. So I guess I don't have really anything brilliant to say like these people, but I think I've been really lucky to kind of ride this wave of statistical need and demand, where the ability to understand a problem, to formulate a statistical approach to it, and to come up with a result, and also to have the skill to present it and translate it to people. Remember Hamish said, is Hamish here? No, he's not. That's time poor. So the ability to present something like that, and if you can't present it, it doesn't count. If you are a pure statistician and it stays only in your head, you don't belong in industry, you belong in pure academic research. And that's phenomenal, right? But you're part of not of the problem. You will find your way into statistics anyhow. But if you have the ability to translate it, and we have to provide the means for people to get there, then you find yourself in the realm of CEO boards and really interesting, challenging problems, and you will get, exactly as you just said, to pick your problem, which is phenomenal, right? I think I'll just conclude saying basically something like, the challenge that now I find, it really is not trying to convey and to say to people how important it is to have good statistical knowledge and computing analysis techniques and the access to big data. Smart, important CEOs and people in the board are really eager to invest in data and solutions and really good jobs for these people, as you can see. But the problem is to actually temper them down and to tell them what are the limitations of big data, what are the requirements of statistics before you can get to a real good solution. These are people that are time poor, as I said, and they are quite quick to jump the gun and grab the number that you gave them and run with it. And your head goes there, right? And it's going to roll once it's wrong. So, I mean, sometimes that happens to me. I just try to tell him, when I was a PhD student, my astrophysics PhD advisor used to tell me, what's the result? And I'll say, well, it's 42. And it's like, well, 42 plus minus what? If you don't have an error bar, it's no science, and I will not hear it. I don't want to hear about it. And when I explain that to the big people in the boards, they love it. It's not that I have to explain it. They really love it. But then they said, okay, what's the margin of error? And they don't like the end of the quote from my advisor, which is, whatever number you got, that's only 10% of the effort. It takes you another 90% of the effort to get a proper confidence interval. They already gone. They already switched off. So that is a challenge I definitely have not figured out, but I guess it's kind of exciting. That's what I have.
Thank you very much, Jose. I love your definition of what statistics is as the language of measurement. And remember in the days when I was asked what I did and I said I was a statistician, I could say then that I was a statistician. Remember someone said to me once, wow, you must know the batting average of every test since the 1930s. It's quite weird, the idea of what a statistician is that some people have. But I do work in the realm of CEO and boards and so on. And you wouldn't believe how often I have to give a little spiel about the difference between random variation and a difference that is significant. And these are people that are making big decisions. They see a graph going up or down and they think the sky's falling in and they want to redirect millions of dollars into a different program just based on random variation. So I think there's an enormous need for people who operate at that level to have a very basic literacy in statistics. So thank you very much, Jose. I'm embarrassed to say that Professor Murray Cameron works at UTS and I've just met him for the first time. That's what I'm embarrassed to say. He is the Director of Industry Doctorates. He has previously been the Director of the Australian Technology Network Industry Doctoral Training Centre, and he was the chief of the CSIRO Mathematical and Information Sciences from 2000 till 2008. So I'm very much looking forward to hearing you speak, Murray.
I'm not embarrassed to know you. Thanks very much, Shirley. Look, I've really enjoyed this morning. I've got something from each of the speakers in the morning session. I've got something from each of the speakers on the panel, so I hope that I can add a little bit more. The first thing I picked up was really the importance of connoisseurs, and I think that really resonates with me. I'm a sceptic about climate, I'm a sceptic about vaccination, I'm a sceptic about antibiotic resistance. I think those are all real problems. What I'm sceptical about is our ability to address those problems, because those are big global problems that require people in democracies around the world to agree some way on a solution. But too many of the people don't understand what a model is and how you test a model and how you believe in it or not. And until people understand models, there's going to be a lot of resistance to change, and the only way we really understand many of these issues is through modelling and looking at the difference between the reality, what we can observe, little bits of data, and the predictions of complex models. So statistics, modelling, how knowledge develops scientifically, the scientific method, critical thinking about these things are all vitally important for our society, I believe. And so there's a really important job to develop a hell of a lot more wine connoisseurs and data analysis connoisseurs than we have at the present time. I find it embarrassing that we have cabinet ministers who seem to not understand the scientific method. Somewhere our education system has failed. I think we have mechanisms for addressing this, and we need to develop more. So there's things like the Significance magazine explains what we do in simple ways. We've got The Conversation as a daily newspaper which is there to explain, transmit complex ideas in simple ways. We should be using that much more. The ABC-run Radio National is a great place for putting out more complex ideas. How often do we hear a statistician on that? When was the last time we read a statistics article in New Idea or the Women's Weekly? But the way we get children to accept statistics ideas are important is in part by getting at their parents through those ways, in accessible ways. So, I think this is really important. we need to be teaching at some level ideas about study design, randomisation, and I said critical thinking. My 2 words for what it's worth are Bell Labs around content, because whilst I think there's not much research from Bell Labs on study design, if you put together the work of many, but in my mind epitomised by John Tukey, John Chambers and Bill Cleveland, you get a hell of a lot of really valuable content for understanding data analysis and critical thinking and explaining. So that's my first point, if you like, about the importance of data connoisseurs and how to develop them. Back in 1994, I was at a conference where David Cox gave the opening address. And 1994 was about the time that data mining was getting going. I think it was before there was serious investment in statistics in the UK. Other than that, my memory is vague. But David Cox said, and he predicted that the following years would be a good time for statistics, but not necessarily statisticians, because there were many other people starting to do statistics. Now, we somehow got through that, but I am really concerned that the future is a good time for data analysis and analytics, but statisticians are somehow missing the boat, and that we are not recognising that there is suddenly a much bigger market for us there. We need to address that much bigger market, and if we don't, we will be, we'll just be consigned to a small irrelevancy. I mean, you know, who studies philosophy now? It's still important. There are still people who do it, but it's not seen as important. I think we run the same risk. I think we need to look realistically at our weaknesses and the threats to statistics, as well as the strengths that we obviously have and the opportunities that are before us. So I guess that's a challenge for the next couple of days and beyond. Someone in a meeting I was at a couple of days ago said, we should deliberately forget things. And I think we should contemplate what things we still think are important, which are actually no longer helping us to achieve what we need to achieve. The third point that I'd like to talk about a little bit is industry doctorates. So we think a lot about school teaching. We think school teaching and what should go into a syllabus in schools. We think quite a lot about undergraduate training and development. I think we don't think very much about PhDs in general. There are many more PhDs trained than there are academic jobs, and yet for most students in most places, the development opportunities you get as a student, PhD student, are to develop you as an academic and no thought for other possible careers. And as a result, we have many people who are really wasted talents, I believe, that they are not getting academic jobs, they are highly able people, and they do not find a good career. So the Industry Doctoral Training Centre is really trying to do a couple of things. One is to build stronger links between industry and universities for research purposes, because Australia is at the bottom of any pecking order you want to think about. We are, 14th out of 15 or 144 out of 145. Just terrible. And we're also trying to prepare PhD students for careers with industry and help industry to understand how a PhD student or a PhD graduate can help their company or their organisation in the long run. So what we emphasise is first, what the students do is first of all a project which is important to the industry partner, and that forms the basis of their PhD research project, which is judged in exactly the same way as a standard PhD. They also do courses in disciplines which are relevant to their research, and they do soft skills training, if you like. So we talk about collaboration and leadership, how to work in a team, how to actually influence a team, how to lead a team either directly or indirectly. We look at business skills and thinking strategically when we encourage students to develop skills to be enterprising and to be entrepreneurial. And entrepreneurialism is much broader than creating a startup, but those sorts of ideas we think are important for students to be able to go from doing a PhD into working in a commercial environment. So to summarise, I think we need to develop many more connoisseurs for a number of reasons. We need to look hard at the threats to statistics and how we address them and what we need to forget. And I think we need to think carefully about how we develop our PhD students for satisfying careers and, you know, in the end, also meeting the needs of industry partners. Thank you.
Thank you very much, Murray. We clearly need to talk more often. Your comment about why we don't have more articles in the New Idea about statistics, I don't know if anyone else has ever read the biography of Ada Lovelace, who, as well as working with Charles Babbage on the difference engine, was a mathematician of some note. And apparently in those days there were no opportunities for women in mathematics to talk to each other. And so they actually did it through the women's magazines, and someone had a criticism that the women's magazines are just full of mathematical proofs these days. So life has changed. Our next panellist is Dr. John Henstridge, who is the Managing Director and Chief Consultant Statistician for Data Analysis Australia. He has over 30 years' experience as a consultant in industry and academia. Now, it says in his bio since 1988, John has nurtured a simple idea into the largest private statistical organisation in Australia. So we can't wait to hear that idea.
Thank you, Shirley. Okay, I'm here in two roles, I suppose, one as an industry statistician and another one as President of the Statistical Society of Australia. But what I'll talk about is my experience from industry, and some of that will feed into what I might say in my role as President of the Stats Society. As was said, I've worked for more than 30 years in industry. Before that, I was at academia. And one thing that's really come through very strongly over all of those years, there are masses of problems out there which need the hand, the eye of a statistician to help solve. And in fact, in my experience, statistics is the most readily applied area of the mathematical sciences. There are just so many problems out there just waiting to be solved. So you might well argue then, or ask, why aren't there lots of statisticians out there making money solving them? Well, there's several reasons for that, I think. One is that we don't have enough connoisseurs out there. We don't have enough people in industry who actually know enough statistics to know that they don't know enough themselves, and therefore they need to go and employ a statistician. So the knowledge deficit that is out there is absolutely massive. If somebody is feeling unwell, They know that they've got to go and probably see a doctor. They don't know much about medicine, but they know they've got to go see a doctor. There is not the corresponding knowledge about the areas where statisticians can be helping them. And as I say, many of these problems out there don't require the very, very latest statistical methods. Often they're very simple, but simple statistics, but applied in the right way, the relevant way. So we are starting with that massive deficit of knowledge there. So anything which increases the number of connoisseurs, particularly if it's wine connoisseurs as well, is important. Secondly, and this is perhaps to explain some of it, statistics is almost universally badly taught. We've told today it's taught really well at Harvard, but we really need to take on some of those ideas there. I can remember my own first course in statistics at Flinders University, which was a low-level course. It was given to all second-year students. It was the compulsory unit for mathematics majors, but it wasn't very deep, and it left me with a feeling of, well, I don't want to do statistics, do I? And it was the classic course of watering down a theoretical course, leaving in the formula and not leaving the understanding there. It was quite fortuitous that I was forced to do more statistics in my third year, not because I wanted to do statistics, but because if I was going to do operations research, which was my passion at the time, I had to do it. And John Darrach, the way he taught statistics was just so amazing that a few lectures from him and my life changed. So that is actually the second thing from that, is the importance of good teaching like that. And it can change people. People will come in from outside. For the last 28 years, I've been running my own company, since 1988. I'm an employer of statisticians. I'm constantly on the lookout for new staff. And that is one area where I find a constant problem. We are not producing enough statistically qualified graduates in Australia. By my reckoning, we're producing at best half, probably more like 1/4 or even less of the number of statisticians that we need. It's quite important that we recognise that this is such a deficit that something has to be done. On several occasions, I've made myself unpopular at UWA, where they talk about modest improvements that they want to get in this number of people graduating in the mathematical sciences, and say, well, maybe we can increase it by 20%. And I say in my normal diplomatic way that, you know, if they're not aiming to quadruple it, then they shouldn't be there, because that's really the magnitude of the change that we've got to bring about. However, sheer numbers is not enough, because it's the quality of the teaching, and in fact you're not going to get the numbers without the quality of the teaching. So the examples this morning of making statistics fun is, I think, really quite critical, and it can be done, and it will draw people in from outside. I'm always amazed at the number of students in their teenagers who get involved with things like the Australian Mathematics competition organised by the Australian Mathematics Trust. There are hundreds of thousands. But we managed to sort of lose them, not just to statistics, but to the mathematical sciences in general. It gets knocked out of them at a later stage. So we've got to do something about that. And the biggest thing is making it sound relevant and fun. And from my experience, statistics can be fun. You know, a few months ago, I was having great fun walking through an ammonium nitrate warehouse, trying to solve a problem that they had there. You know, knowing that I was walking on a gangplank over roughly 15,000 tonnes of explosives. You know, these things can be fun. And there are lots of things that we do like that there. So it is a great career. And we have to do it. Probably the last thing I'd say in that regard, that what we've got there for is partly a teaching problem, but also a marketing problem for that. People talk about whether we should be selling ourselves as being statisticians or data scientists. I do a lot of work in market research as well, so I know a bit about branding and things like that. And one of the most important things in branding is just to be consistent. Be consistent and be clear what you are and clear what you're not. I think statistics is the right word to use. So I describe myself as a statistician. On my business card it says consultant statistician. Statistician is the noun. I'm not a statistical consultant, I'm a consultant statistician. That's where I am. And I'm quite strong on that branding, and I think it's branding that we should have. I think it's important to differentiate ourselves from people who are data people purely, because that gets soaked up in this computer science thing, which is of value in itself, but often the level of statistical knowledge that you see exhibited in that area is woefully inadequate. I won't say it's their fault, because we're the ones who are trying to teach them statistics. We've failed. But that branding, I think, is very important as a statistician. There are various things like that which I think are very important. The Statistical Society of Australia does have an accreditation program for both statisticians as individuals and for statistics courses. And I think there's activities like that which help us say, well, this person really has got some substance. And therefore can be trusted with other people's problems. And I think that's what a good statistician is really good at. It is solving other people's problems. Thank you.
Thank you very much, John. I think that was a very brave thing to say, that statistics is almost universally badly taught. Because sitting next to you and our final speaker is Dr. Peter Howley, who I haven't met either, but I know his work very well. He's a senior lecturer in statistics at the University of Newcastle, and he is nationally and internationally recognised as a leader and award-winning academic in statistics and education. The reason I know his work well is that I'm the chair of the Australian National Teaching Awards, and he won one of those awards last year. So we know that he's the exception to John's rule. So over to you, Pete.
Thank you very much. I'd like to start with something that's been itching me all day. I want to know primary, secondary, tertiary and industry. Who's here? So who do we have from primary? Anyone? Okay, a few. 1, 2, 3, 4, 5. Thank you. From secondary? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. Tertiary? And any industry still? Excellent. Great. Thank you. So we do have representation from all elements, and that was something that was key for this event, that we did have the representation from some people cradle to the very end. Look, what I want to start with, has anyone, except from hearing it from me today, heard of CS plus X? Just a few? Okay.
Heard it from you last night?
Yes, thank you. Okay, yeah, good point. So CS representing computer sciences. So computer science plus X. And Stanford talks about it in terms of integrating humanities and computer sciences. And they talk about it being a new type of engineer, a new type of humanist. And I heard Google's Marianne Williams talk about it as well, saying that students are increasingly excited about computer science if they can combine it with their passion. This is what's been alluded to in many of the talks today, of course. They talk about CS plus retail, brought online shopping, or CS plus the automobile and the driverless cars. So my question is, why aren't we doing this with statistics? We say statistics is everywhere, we say it's interdisciplinary. Do we show it? Do the students feel it? And do they get to engage in it and live it? Do we do it, because some people do, I'm not going to say everyone doesn't, but do we do it to a point that it wins others over? And by others, I mean the ones who perhaps weren't leaning towards doing statistics, because they possibly saw it as, well, I can't do maths, so it's not accessible to me. So do we do it in a way that makes it clear that stats is actually accessible to a wider group? And this is about expanding that funnel of people who are coming through who can actually become statisticians. And do we do it in a way that creates the grapevine and the nice taxi conversation, as Ming Lee mentioned? Do we do it in a way that we don't have to actually beat our own drum, that others are going to start the hum and create the talk for us? Because I think that's where we need to head, and we need to create that. How? Well, that's what we're going to be discussing in the Q&A later as well as tomorrow. But we need to widen that funnel, we need to tap into existing interests and build on it. I think that's one of the keys. So that CSS plus X model, is it stats plus X? Is it, in parentheses, stats plus CS plus X? perhaps that's how we can move forward. I think context, again, this was mentioned by Zhao Li and others, about we lose them if we go straight to the stat methods and the formulae. And so the chemistry of wine, you lose them if you go straight to the chemistry. So similarly, the context is critical. It's more appealing to learn if you can see the reason for why. And so setting that up initially, and the underlying idea of statistical investigations, it sort of underpins everything that we do as a statistician. And so at the tertiary level, we can create that with industry links. At the secondary level, we can create it by actually, and I'll mention the National Stats Poster Competition, it does this, or attempts to do this, where students get to look at a topic of their own interest, and then they have a question relating to that, and then they do their investigation. So setting it from a point where they're identifying the field that they want to look at, and then combining with statistics can help to widen that funnel perhaps. As Jose mentioned, people love to measure. They like to compare. Things like, am I getting the best deal? What does sugar do to me? Will this vitamin help? Is the climate changing? Or who won state of origin? It's all of these questions that are all underpinning it is about measurement. Not everyone will see that. I don't mean from this audience, but from the people who are asking those questions. And we know one of the critical steps is turning a business or industry question into one for which we can get an answer, and then working backwards. So I believe we need to tap into such interests. So show it's accessible, not hidden within maths. Authentic linking to what people know or are comfortable with will help to bring them towards statistics. And as I say this, I need to probably make the point, we need to have statistics having its own identity as well, that it's not just with everything else. So we need that twofold approach. The identity of statistical thinking, understanding variation, the error bars that were alluded to, and the skills that a statistician does bring. So I think we need two streams. I think we need the math-centred orientation, and they're probably, maybe generalising, saying they're going to be the ones who develop the statistical methods beyond. And then we also need the non-math-centred people, and that's what I think we haven't been doing a particularly good job with, I guess, in getting people in who have an interest, or at least have the intuition or ancillary interest or something that we can actually build upon. Is anyone familiar with moon shooting? I watched it, yes, moon shooting. It's 3.5 minutes, I watched it on YouTube last night, and it was all about the idea of they start with this problem, we're going to get to the moon somehow. Then we work out how we're going to get there. It starts with a problem, then we work out how to solve. And I think that context can work really nicely with statistics. And I'm not saying I'm the first person who said this, a lot of the other speakers have said it. Schools, in terms of helping with obviously the supply chain that are coming through into tertiary, they need support, and that support, I believe, shouldn't be at arm's length. If we're going to develop resources, that's terrific, but we need to be working with the schools. Teachers have a lot to do, and to have to then try and learn statistics to then teach statistics, we need to integrate and work with them on anything of that nature. And I know there's lots of schools, but there are potential methods if we think about the problem that we need to solve, that we're going to solve it, so that we can actually make sure that we are getting into all of the schools. There's links that we have, so we need to get industry into the schools as well, and the tertiary. And there are initiatives that are doing that as well. It was mentioned earlier about James Baglan and his Islands in Schools and working with them. There's also the National Stats Poster Comp that gets industry people there, and the CSIRO's scientists and mathematicians in schools. We need to consolidate and build upon these ideas, and many others that probably exist, and I'm sorry if I didn't mention them then. So I think what I'm saying is we have a great opportunity if we work together, consolidate, and then support teachers. But I'll just reiterate, support teachers, but not at arm's length, working with them so that they can upskill or whatever is required. I mentioned this last night, and I'm not saying it's the solution, but it's an idea. A teacher actually contacted the Stats Society and myself and asked, from Queensland, and said, we need professional development. And I think it's a very positive note that they're contacting us. I think that's one thing. And the second is, how do we get to all the schools? Do we create these MOOCs or resources and such? Well, we do have the benefit of technology. So access grid rooms and those sort of technologies, where we can actually link through all of the universities. And we can have one single presenter in one place, and we can bring the schools to the universities where the access grid rooms are, so we can start to connect with them in that way, and then we can also start to help them through that network. And I got a positive response from that when I mentioned it to the teacher. She said, our video conferencing isn't that great at our school, so it'd be great to go to a university and do such things. So there is interest if we can think of good solutions for that problem. I think some of the challenges at tertiary, we are continually being asked to self-promote and show the individual. What did you do in anything? And this alludes to what Louise was talking about. You need to be able to say, I got this grant, or such and such. And I think we need to recognise that as a problem that we need to solve, and how we can collaborate, recognise the team, recognise the individuals, recognise everyone as a group, and it's everyone's contributed to where we take it to the next level. I think that's a challenge that we need to consider when we're moving forward, how we're going to best do that. A couple of other things. I see statistics as a connecting force. Has anyone heard of iSTEM? It's a new New South Wales endorsed course. iSTEM is integrated STEM, even though STEM doesn't actually stand for what we traditionally know, because they weren't allowed to use science, technology, engineering, maths. But essentially, it's project-based learning activities, and there's a series of modules where students will get an activity and they'll learn about surveying or mechatronics or these different areas. And I was fortunate, they asked for a stats one as well, so we've got a stats in action one there as well. But my point is that the way that it works, or the way that I'd like stats to operate, is it's not seen as competition, because STEM in itself can be seen, if it's a STEM course, so they're teaching science, technology, engineering and maths, but I teach maths over here and I teach science here and so forth. What it uses iSTEM as a platform to bring those other teachers in and to be able to show the students when they're working on their robots and such, see the maths that we taught you in this course, you're actually using it here. And so working with the teachers, it's not seen as competition, we're actually collaborating. I think that's an important point that we need to consider when we're moving forward with stats, that we're not seen as trying to take ground from others, but we're actually working with others to establish new ground. Look, there is also the other difficulty, and this is one of those, it's a problem we have to solve, but there are many academics who their comment is, I like the traditional way of teaching statistics. And so we need to be mindful of that. I support all of the talks that have been mentioned. They all get me excited, actually, from Nick and Louise and such. It makes me think, yeah, that's where we need to be, but we need to be mindful of these other challenges, and that's what we're going to talk about in tomorrow's workshop and try and come up with some ideas. And I think the other thing that I just wanted to reiterate is that culture, which is what Jackie mentioned, and developing a culture within Australia takes the collective, and I think that's what we are here for at this colloquium and tomorrow's workshop, which I look forward to as well tomorrow, so thank you.
Thank you very much, Peter. So our panel today is really called STEMs, How to Put Statistics into STEM in the Age of Data. And I saw a figure recently that said there that jobs requiring STEM, and let's just decide to call it STEMs, jobs requiring STEM are growing at a rate that's 50% faster than non-STEM jobs. But we are graduating students without STEM, which is 70% greater than the number of graduates with STEM. So there's an enormous mismatch there, and I think we've heard that in the panel today. So after listening to all of the speakers, I think our big question actually begins with the Board of Studies. How do we capture students in K to 12 to be as excited by data and mathematics as probably everybody in this room is, and then how do we continue that through into university to produce a whole range of people, from very detailed PhDs in mathematics and statistics to everyday workers who are going to be looking at a future of jobs which is all digital and data, so that they really understand what an average is, and they understand what random variation is, and there's a whole range of things that they really need to understand. So it's just a small problem that I'll now open to the audience. We've got about 10 minutes for questions. Yes, right down the front. There's a mic coming.
Sorry, I'm not going to answer that question because that's my job, but I was going to ask, if that's okay, John, a question, which is the branding issue, because I think it doesn't sound very important, but branding is really important. And I just am just a bit confused about if this brand of statistician isn't being very successful in achieving the goals of getting more kids to do statistics and people to recognise how important it is. Why wouldn't you change the name of the brand to make it something that people do think is important and then be very consistent with that new brand?
That's a very good question, and I suppose there's a couple of issues there. One is that while statistics is very relevant to the modern world, I would contend that it's been very relevant for the last 100 years. It's 100 years of knowledge that has been built up there. There is a lot of talk these days, for example, of big data, and I would contend that statisticians have been working with big data for the last 100 years. The most famous photograph of Ronald Fisher, the statistician, was with him sitting at what was one of the highest powered computing engines of the time, the millionaire calculator, mechanical calculator. So statisticians have been working with big data, I would think, for forever, and that's not really the defining thing there today. As I said earlier, I think some of the other terminology that is used is confusing, and some of the things like data analyst, that other people have taken those words there. And finally, I would say that we have created some of these problems for ourselves there, and we've got to correct that. One of the problems is that you get people saying, well, I'm not a statistician, I'm really a biostatistician, or I'm a biomathematician, or I'm an informatics, or I'm a genomics person. They're all doing statistics, and statistics actually provides an incredible set of generic tools which can be applied almost anywhere. I can't think of a single statistical tool that I've ever used in my life that I've only used in one area of application. So the unifying feature there is the statistics there. So if we were going to choose a different name, it would have to be something that would unify the subject there, and it would have to be something which would distinguish us from these other sort of come-lately subjects, shall we say, there. Now, I don't know of an alternative. I suppose that's part of it. I don't know of an alternative. But I'm very aware that, in branding like that, the name is one aspect of it, and I think what I was saying there really is that you've got to have a brand which is, you're consistent in the way you use it, it distinguishes you, but you've also got to but simply a name in itself is not enough. You've actually got to associate that brand with good connotations. Sex is the standard one. Alcohol is another one. but there are things, it's got to be seen to be a good career, a fun career like that.
Maybe I could just say something about that as well. So AMSI produces this thing called Maths Ads every year, and we inherit it from La Trobe. We've been doing it forever, and there's some descriptive stuff in the front, and it identifies this anonymity problem that mathematical scientists have. We're almost all employed in jobs whose titles don't relate to what we are as professionals, and this is problematic for parents, because for all the reasons John said before and so on. There is a solution to this. We need to give the public a clear identity of the mathematical scientist, the mathematically capable, statistically capable professional. Engineers are called mechanical engineer, civil engineer. Lawyers are called property lawyers or defence lawyers or whatever, all of that sort of stuff. And John calls himself a consultant statistician. So I think the brand is good. I think mathematician's a good brand, statistician's a good brand, computer scientists, whatever. And I think we should move to that situation. So we get meteorologists, instead of calling themselves meteorologists, we'd get them to call themselves meteorological mathematicians or something. So they get on the radio, as John said, they get on the radio and talk about, the computer model says it's going to rain tomorrow. Well, sorry, that's a mathematical model that's going to talk about that tomorrow, or a data model, right? And we're too keen to adopt the identity of the domain we work in, and we don't identify ourselves clearly enough. We need to work that out. So I wouldn't be hiding anything. I wouldn't be calling it, stop calling it a statistician, call it a spade. A spade is a spade, it's a statistician. And we need to convince the world that this is what statisticians do. They work here, here and here, and we should be adopting statistician as part of the name.
There's another way of expressing that. We should be saying, I'm a statistician, I'm John, I'm a statistician, and I'm proud of it. Rather than like the sort of Alcoholics Anonymous thing, I'm John and I'm a statistician.
A final question.
These are basically comments for Murray and John. What should we forget, was Murray's comment, and Nick supported dramatic changes. And I will speak again about this later on, I'm sure, but the first thing to go is the central limit theorem, and the second thing is the t-test. The t-test should go to a second course. It's not a principle of statistics to do the t-test, and the central limit theorem has no force as an inferential principle. These should be removed or put somewhere else. John asked, where are the statisticians to help industry? And statisticians of my generation, especially in the UK, who took early retirement in large numbers, are out there, but they're working as consultants in industry and not visible. In my case, for the US Department of Education for the last 12 years, since I left the UK, because I'm working in advanced psychometric modelling for large-scale educational testing. This is a particularly arcane area with a steep learning curve, which I managed 40 years ago. I'd rather do consulting work in Australia. I've had several ARC grants since coming back here, but they're at my expense because I'm an honorary. The US pays me, but it won't pay Australian overheads. And this is a continuing source of unpleasantness with the University of Melbourne that wants my grants, but they must come with overheads.
Anyone like to respond? No? So should I take that as a statement rather than a question? A la Q&A. All right, I think unfortunately our time is up. I think... sorry? Oh, John, okay, someone's overruled me. Another last question.
That's so embarrassing, delaying everybody's afternoon tea. Thank you. I do think there is a sort of a lurking problem in the definition of what we're talking about by statistics, and there's a kind of a defensiveness around the name and the profession that we all feel with some justification loyal to and affiliated with. But I genuinely feel that in the modern world, we're just being overtaken. So there are so many of these data science initiatives, especially in North America, that are taking off at a rate of knots and not really involving a lot of statisticians, a lot of statistics departments. And it struck me this morning listening to Helen from the Commonwealth Department talking about all the analysts in the public service and that they need more data analysts and they're building their data capacity. And I wanted to ask her, can you tell the difference between a statistician and a data analyst? Do you know that, is there a difference? Have we communicated those issues? I don't think anybody today has really defined statistics in an adequate way that would communicate to people like Helen around why statistics is more important than machine learning or other computational science skills, methods and ways of thinking that are becoming more dominant with large amounts of data. I'm not saying the case can't be made, but I don't think it's being made very clearly. And on the other hand, I think statistics has a lot to answer for in terms of teaching people bad habits. We sell snake oil in some areas. We sell statistics as a bag of tricks, sort of techniques for drawing conclusions in a definitive way, where in fact we should be teaching people that statistics is about defining uncertainty, and that you often cannot draw conclusions that the famous sort of illusions around statistical significance. It's now widely sort of analysed as the source of the cause of a huge amount of bad science going around out there. And yet we perpetuate a lot of those teaching approaches in what we put out there. So I think it's more complicated. I'm sorry, I've tried to put a lot of points in there I've been thinking about all day. And it's not really a question, but we can ponder them further maybe.
Well, I couldn't agree more. I mean, we find a lot of people have this natural tendency to oversimplify and to be deterministic rather than statistical. So they just don't see the uncertainty. They just want this result and then run with it. And I found a lot of problems sometimes in kind of low or mid management and all the way up. They have this incredible quick tendency to just group IT people, an analyst, a statistician, and a modeler. They're just the data crunchers or something stupid like that. I'm not care. And it takes a lot of effort to just go and educate the nuances and the differences. And to do some simple demographics is nothing compared to do a model and what to validate a model is. It's a huge challenge. And as I say, my big challenge is not to say there's a lot of value in statistics. They are ready for that. It's just to say there's a lot of nuances and differences that need to be propagated and educated upwards.
I just want to say that if we think that other disciplines have run with an idea which we think we should have a part in without us, then it's our fault.